The essential question for this video is, how do I derive the equation of a circle using the Pythagorean theorem? How do I derive the equation of a circle using the Pythagorean theorem? And this may seem complicated as we go through it, but hopefully if you listen to the audio of this video, it'll make pretty good sense to you as to how do we find the standard form of a circle. So take a look at our previous video. You see the standard form of a circle is x minus h squared plus y minus k squared equals radius squared. Let's see where that comes from. So I'll read the text here. If the center of a circle is labeled as hk, let's do that. So here's our center, and we're going to label this as h comma k, hk. And a point on the circle is labeled as xy. We've done this before with finding the functions of parabolas. Let's pick a point here. I'm going to pick one right here. And let's label that as x comma y. There's our known point on the circle. Okay? Then we can use the Pythagorean theorem to find the equation of every circle. Again, this gets a little tricky because we're not going to use any numbers. We're only going to use variables. But watch and follow along and see if you can grasp this. Let's go ahead and connect the center to our known point. That is the radius of the circle. Let's go ahead and label that, though, as c, because for Pythagorean theorem, that's going to be our hypotenuse, or our c value. Now let's go ahead and label our two legs. I'm going to make a right triangle in order to use the Pythagorean theorem. So there is one leg. There is the other leg. And we're going to label those as, let's label this one as A. And then we'll label this one as B. Now here's the tricky part that threw me off when I was in high school, so hopefully you get this. If our center is at HK, I want you to think about this. This point right here, the right angle of the triangle, that point right there, notice the x value has not changed. It's exactly horizontal from the center. That means this coordinate still has a value of h for the x value is h. Let me look at this a second here. Actually, I'm sorry, I misspoke on that, class. The h value actually changes. This is the x value. We're moving on the x-axis. So actually, this has the same value as the x value of the coordinate on top. Here is x. This is actually x. And then look at, I made a mistake here. This is the k value. This is the y value. As you move horizontally, your y value does not change. So this is still going to be k. Draw that a little bit clearer so you can read that better on your phones if you're using your phones. So that's x comma k. Again, I'll talk about this one more time. The y value when you move horizontally doesn't change. The x value does change. The x value is no longer h. Since it's right below this point that we labeled x comma y, the x value of this coordinate is the same as the x value of this coordinate. That means if this is x, then this is also x. So if you look at this, let's take a look at the two things that come about from this. We can rewrite what A is. A is actually how far we traveled on the x-axis. Well, we traveled from h to x, this distance right here. So to find the length of A, we could actually just rewrite that as x minus h. Think about that. If this were 5, if x is 5 here and h is 1, then the distance between this and this is 5 minus 1, which is 4. So there's the a value. The b value, we can do the same kind of thing. We can take a look at the b value and say, well, we started right here at the top. This is y. So the value at this point right here, the y value of this point is actually y. And we're going to travel all the way to here. How do I find the distance between these 2 points, or the value of b? It's y minus k. So again, I know it gets tricky when we're just using variables, but all I did was figure out that based on these 3 points, then the length of side A is just x minus h, and the length of side B is just y minus k. And one more thing we can label here, this c value right here, that's actually the radius of our circle. So I can just write r. That's our radius r. Alright, now knowing that, let's write the Pythagorean theorem and watch how we get the equation of a circle. So the Pythagorean theorem is a squared plus b squared equals c squared. If you got a right triangle, you know the square of the 2 legs added together, the squares of the 2 legs added together equal the square of the hypotenuse. Well, let's substitute what we just figured out. We just said, well, wait a second, we can substitute for a in this case. We can say that is x minus h squared. And for b in our example is just y minus k squared. And our c value is actually the radius. We can substitute r for c, and that's the radius squared. And take a look. That is the standard form of a circle. It comes directly from the Pythagorean theorem. And this equation defines every point around the circle. So let's go ahead and make that note. This equation defines every point around the circle. So it doesn't matter where we are, no matter where this point is on the circle. If you make a right triangle and you label it A, B, and C, A will always be x minus h, and B will always be y minus k, and C will always be the radius. So every point around the circle. And that is how we actually get the standard form of a circle using the Pythagorean theorem.